Hey guys, welcome back. Behind me is my 1999 Ford F350, and today we're going to be troubleshooting the automatic four-wheel drive. Whenever I shift into four-wheel drive, the auto hubs do not automatically lock in, and that's something that is kind of inconvenient, but I've put up with it for 4 or 5 years. I just get out and lock the hubs whenever I need it. But today we're gonna actually diagnose it, figure out what's going on, and see if we can fix it. So this system has a electronic shift on the fly 4x4 switch. So when you're driving down the road, you should be able to just flip it over to four-wheel drive high, and the vehicle will shift into four-wheel drive and then lock in the front hubs. Mine will lock in the transfer case, but it will not lock in the front hubs. And that uses kind of two different separate systems. The transfer case has an electronic shift motor down below our feet, and then the front hubs use a vacuum system underneath the hood. Now, if you're using a diesel truck, the vacuum system is shared with the climate control. My climate control works perfect. You know, air comes out my vents, it comes out the floor, defrost, all the controls work. So I know that my vacuum pump is still good. Now, the vacuum pump is mounted underneath the hood. We are on the passenger side of the vehicle. Here's my battery. The vacuum pump is mounted right down here. So if your vacuum pump is bad, you will likely have airflow just out of the defrost, and your 4x4 system will also not work. The other important part of the system is this guy here, this solenoid. This is a couple different names for this one. They call this the shift on the fly solenoid or the pulse vacuum hublock solenoid. Either one, depending on where you're looking for parts, is going to be the name for this part. Now, if this part is bad, then I won't be able to get vacuum down to the hubs to enable them. And that could be what our problem is here today, but we're going to prove to find out why, because these systems have a strange operational design where this will enable vacuum to the hubs for 45 seconds, and then it cuts the vacuum, but the hubs are supposed to stay locked in. So if you have a vehicle that is only locking into four-wheel drive for 45 seconds and then it disables, more than likely this isn't your problem, because this is doing its job. It's enabling it for 45 seconds, and then when the vacuum gets cut, the hubs aren't staying locked in. They kind of operate like a ballpoint pen. You know, when you click a pen, it locks down. That's the theory behind the hubs. So this is applying enough vacuum or force to lock it down, and then it releases it. And then to unlock it, it applies just a little bit of pressure or a little bit of vacuum to get it to click back up. So we're going to go through it, we're going to test it. Sometimes these vacuum hoses crack, sometimes they break, sometimes you have leaks. And I don't know on this system, I don't think that it enables for 45 seconds, but we'll have to double check that. And sorry for the chattering birds. Filming at my house today, and all the birds are happy that the rain has stopped. So, you know, they're going to be a little bit noisy today. So I'm going to use my trusty old vacuum gauge here. We're going to disconnect this line. This line comes to the solenoid, and it goes down to the hubs. I'm going to hook my vacuum gauge in there, and I'm just going to turn the key on. On this diesel truck, I should be able to just turn the key on to get the vacuum pump to run. If you're running a gas vehicle, then you will have to have the vehicle running. But let's try turning the key on, and we will just, you know, cycle that switch and see if we have vacuum coming out of here. So it does look like we are building vacuum. May not be a whole lot. I didn't run the truck before this test to fill up the reservoir. The reservoir is mounted right here. So at this point, it is filling up the reservoir as well as running back into this line. Now, I'm in Colorado. My vacuum levels or readings are going to be a little bit lower than what you'd see at sea level. But typically what we're going to look for here is, you know, 12 to 16 inches, and there's our 40-second timer, and it just shut off. So we know that we are getting vacuum through this solenoid, and it should be going out to the hubs. So now that we know that we have vacuum coming through there, let's check the system for leaks. This other hose that goes down to the hubs, if we connect our vacuum pump to it, we should be able to pump up vacuum, and it should hold. Now, it takes a while to pump up the vacuum enough, even without a leak. So, you know, we may be here for a little bit. Let's see. And this may be our problem. Maybe I just don't have any vacuum going down to the four-wheel drive system. And I think that's what our problem is. So now what we're gonna do is we're gonna move down to the hub and see which side of the vehicle is causing our vacuum leak. Because there's a couple other places that we can have a leak. Okay, I'm looking through the passenger fender and I already see an issue. Right here is my vacuum line that comes down from my hub, and there's nothing attached to it. It's just open right here. There should be a vacuum line that follows this brake line up and attaches right there. So let's crawl underneath and see where that vacuum line went. So there's supposed to be a vacuum line from this little vacuum fitting. It's kind of hard to see, especially with my hand in the way. But right there is a little vacuum fitting on the knuckle. There's supposed to be a vacuum hose from there up to the frame rail. So let me see if I have a piece of vacuum hose and we can just hook it on there and hook it up to the frame rail. That could be our whole problem. So I sacrificed some of the long vacuum hose I had on my vacuum pump to fix this area. I often keep a really long section on my vacuum pump just for cutting a bit off here and there to patch vacuum lines. But I probably need another zip tie because this is a little smaller than the OEM stuff. Zip tie it to this brake hose and that should be good to go. Now let's go ahead and go back up top, use the vacuum pump again, and see if we can identify any other leaks. Okay, so I got it pumped up. We're at 16 inches of vacuum. It is very, very slowly decaying, and that could be a leak in my vacuum pump here. This is kind of an old unit. It's seen better days, so we have a little bit of a leak. But if it's just a minor leak, normally the vacuum pump can overcome it. So let's go ahead and test the operation of this. I'll hook the hose back up to how it should be. I'll turn the key back on. And I think what I'm gonna do is I'm gonna let that vacuum pump run for a few minutes and build up the vacuum in the canister before we find out if it's going to enable our hubs. Now, because I got stuck in the mud the other day, my hubs are locked in. Let's unlock those. So they should be in auto mode now. And they seem like they're still locked in. So if I zoom in here, we can see the front drive shaft spinning. I have just this one tire off the ground, just about an inch. So I have them unlocked and my front drive shaft is spinning. If the other side was unlocked, then the axle would spin and that drive shaft shouldn't spin, but we better double check. So we'll just reach in here. Yeah, I can't rotate the axle. So this side is locked in as well. Now you remember earlier when I said that it uses a small amount of vacuum to unlock them? We might be missing that small amount of vacuum. And that could be caused by the pulse modulated or pulse vacuum hub lock solenoid or shift on the fly solenoid. If part of that solenoid is bad, then it won't be able to give it that low amount of vacuum that's required. So I think we should, let's go a little more advanced here and I'll give you a better visual on the screen. We are going to hook up our lab scope to the wires on that solenoid and see if we can watch the body control module, which is the 4x4 control module on these, the GEM module. Let's watch it command that solenoid for the four-wheel drive position and the two-wheel drive position. And then we're also gonna hook up a pressure transducer and watch the vacuum. Now you can do this all manually with basic test tools, but since we have the snap-on scope and the pressure transducer, let's go ahead and hook that up just so we can see it on the screen what everything is doing. So I have the Zeus Plus. We have our scan module. So what I'm going to do is channel 1, hook this yellow lead up. Now we have multiple grounds to connect. You don't want to stack them all onto this post. If you stack them, you're more likely to break them. So in the factory leads from Snap-on, they give you this short lead that's just a 90, and then they give you another lead that is a male and female, so that you can stack your shielded cables together. Same thing if you add an amp clamp to this, you would hook your negative to to this and not to this, unless you're using the amp clamp by itself. So our yellow lead's the only one that's gonna have our actual ground cable here that connects to the vehicle. The green lead, it's just shielded to reduce noise, but it doesn't have a ground connection on this end. So we will find a ground with the batteries right over there next to it, so that'll be perfect. So that can go over there. The green lead's gonna go over there as well. I'm just gonna grab a couple of back piercing probes. Ignore that one is black and one is red, that doesn't matter. And then I also have the pressure transducer adapter connected. It connects to this DB connector on the top here. And that's gonna supply our power to the pressure transducers. Now, I have the adapter from the original Zeus. The leads are a little too short for the Zeus Plus scan module. They do have a revised version that has longer leads, but I'm just using a 6-inch extension lead. Ignore that it's black, and I'm connected to channel 3. From here, we have our breakout cable to our pressure transducers. Now, this is a 100 PSI transducer, but we're only gonna use it for checking vacuum. Now, I haven't checked a lot of vacuum sources with this, so we'll see how it does today. So let's go ahead and, on the Zeus, we're gonna go to scope multimeter. We're going to go to, we can do lab scope or graphing multimeter. These aren't real fast signals, so it shouldn't really matter. Go to 4-channel lab scope. And then we need to select our channels. So channel 1 and 2 are both going to be voltage, and channel 3 we are going to use vacuum 100. So the vacuum 100 uses the 100 PSI probe, but we're only going to be looking at the vacuum side of it. Make sure it's not connected to the vehicle, which we are not, and it's going to calibrate it. It's basically going to zero it for our altitude. We'll hit OK. And we can see that squiggly blue line is right around the 0 mark. Let's go ahead and connect our vacuum pump to it just to see, how it reads. And I probably don't have the best fitting on here. I have a quick disconnect fitting for my fuel pressure stuff. And when vacuum is applied, it is going to show positive. So what I'm going to do is I'm going to just disconnect our lines going to our hubs. We're just going to plug this in right there, and then we'll hook up our scope leads, and we'll just see if this solenoid is doing what it's supposed to be doing, sending vacuum out to the hubs. So I know from a vehicle I looked at earlier in the week that the center wire on this solenoid is our power source, and the outer 2 wires are the wires that the body control or the GEM module is going to pull to ground to activate this solenoid. So I just want to stick my back probe in here. I'm not piercing the wire. I'm just going next to the wire through the rubber grommet and touching the contact. And what I want to see is I want to see battery voltage on both of these wires. And we may see battery voltage if we connect our ground. No. And actually, I'm going to back out of here and I'm going to go back to the graphing multimeter, just because it has a larger time base, and I think we may want that. Okay, I'm going to probe the center wire and verify that we have power. Okay, we have power there. So maybe I'm just missing our mark here on the outer wire. There we go. I just didn't have a good connection. Let's see if the same holds true for this wire. There we go. Okay. Poor connections, operator error. So we're in 2-wheel drive mode right now. I'm going to go inside. I'm going to flip the switch to 4-wheel drive. It's going to activate this solenoid, and it's going to change the vacuum going out to this. The pump's going to kick on because we're going to lose a little bit of vacuum in the line here. And then once it builds up enough vacuum again, the pump will shut off. After 45 seconds, the solenoid will shut off. Our vacuum in this section should bleed off. So let's simulate that, or turn four-wheel drive on and see what happens. So we instantly jumped up to a little over 14 inches of vacuum. Both wires got pulled down to ground. And I guess I forgot to mention, since we are seeing, before it activates it, since we saw voltage on this wire and this wire, that means that we don't have an open circuit in here. Now our resistance could be wrong, we could have high resistance, but at least it's not an open circuit, so we know that we have a good connection in our connector. We should be getting close to that 45-second mark. There we go. It just released both of them and released our vacuum. Our vacuum dropped back down to 0. So at that point, our hubs should be locked in. Keep in mind, I have this disconnected from our axle. We're just testing the vacuum system and the solenoid. So let's go to two-wheel drive. In two-wheel drive, we should just see like half as much vacuum, and only one of those wires is going to get pulled to ground. And that's what we see. So let me change our scaling here a little bit. We are currently at 6.3 inches of vacuum. Now it doesn't run that quite as long, 15 to 20 seconds is normal, and it released it. So this whole section of our system is good. Now we can stop this and zoom out. So now on the screen we can see, our blue line at the bottom. And then we see the yellow and green are up high. When the yellow and green get pulled down to ground, the blue jumps up. And then 45 seconds later, it releases the yellow and the green wire. Our blue, which is our vacuum, drops back down to 0. And we could add a cursor to measure how much vacuum we have. So at cursor number 1, we had 14.3 inches of vacuum. Cursor number 2, we are at just under 0. Let me just slide cursor number 2, oops, over to the two-wheel drive position. Because what it does is, like I said, we had no vacuum, no command, high vacuum, command on both wires, no vacuum, no command again, because our hubs should have locked in and stayed locked in, just like a ballpoint pen. And then to unlock it, we're only going to command one of those wires to pull to ground, and it's going to give us a little less than half the vacuum. So we have 6.33 inches of vacuum. Now this picture will look a little different when we have the hubs tied into the equation. Okay, we're losing daylight here. I went and stole a vacuum tee off of one of my other vehicles. So now we're teed into the system. Hopefully this tee will work. It's for a boost gauge, so it has an orifice in that port. But we're not going to be moving a lot of volume of air through here. Just basically a measurement port, so hardly any movement. So it should read accurately. We'll make sure that our screen is still recording. I'll turn the key back on. So we have our power. That small drop is just a glow plug solenoid clicking in. The voltage is dropping down to about 11 volts. It'll shut off here in a second, but it won't affect our readings. I'm gonna go ahead and click it to four-wheel drive. We can hear that vacuum pump kick on. We can see our vacuum rising, rising, rising. Our current vacuum down at the bottom of the screen. We're almost to 12 inches of vacuum. And that's the biggest reason why they energize that for 45 seconds, is so that it has enough time for the vacuum pump to build, or if you're running a gasoline engine, so it has enough time for vacuum to be pulled through the whole thing and to pull those hubs all the way in. So we're at 13 inches. And it just shut off. So our hubs should be locked in, and since our transfer case is locked in, let's see if we're locked into four-wheel drive. we are locked into four-wheel drive. Let's flip the switch back to two-wheel drive and see if they will unlock. So we have one solenoid activated. We are sitting at 6.3 inches of vacuum, and it just released it. Okay, this hub unlocked. Let's crawl underneath and see if the other one unlocked. Actually, I can just manually lock this one in. I don't see my drive shaft spinning down there, which means that the other side is unlocked. Now we can throw the camera underneath there and just verify that. We should see the axle spinning. Yep, I can see the axle rotating, which means that side is unlocked. Okay, this side is unlocked. Now let's go ahead and run through this a couple of times. So let's go ahead and kick it back to forward drive. Stress test the system a little bit. We're going to cycle it back and forth, verify that everything is operational. Okay, I'm not sure what happened, but something happened. We didn't build the vacuum we needed to that time. Vacuum pump is still running, so if it doesn't shut off shortly, we will have to, it's like his voice activated. We'll have to verify if the vacuum pump is capable of building enough vacuum, because that could be our issue now as well, is that vacuum pump could be getting tired or the solenoid could be tired. That's why I like to cycle them a couple of times, because I'm sure that I've looked at the vacuum lines in the past and I didn't have an issue that I've been dealing with for 5 years because of a line that was missing. I figured there was something else going on and it didn't really bother me. Now it also looks like I lost connection through my green trace. I'm showing 0.5 volt. So I think this solenoid is bad. Now I'm just gonna hit stop and I'm gonna zoom out. Very interesting. I wish I would have noticed before we started, this last capture, if my green trace was sitting at 0 or not. So basically what's happened is, we've cycled this a few times, and that winding, I think that winding just went open circuit, because we should be seeing 12 volts on both sides of this. The only reason we wouldn't is if, one, this wire got shorted to ground, which I don't think is the case because we don't have any vacuum going through, or two, the winding internal, the resistance went up as this unit warmed up. So we're sitting at 0.5 volt on this one side, and we're sitting at 11.8 volts on the other side. Now let me go back to two-wheel drive. I don't remember which one of the wires was our two-wheel drive activation. So it looks like our green wire is our two-wheel drive activation, because nothing happened. The yellow wire didn't get pulled to ground. So now that we have that fault, it looks like we need to check the resistance of this solenoid. And can we flex it? Sometimes you can flex electronics and get them to make connection again. Ooh. So that's why it's important to always stress test things. So now we're going to do something a little different. We need to switch to a ohm meter. So let's go back on the Zeus. And we don't need to graph resistance, I don't think. We can just go to a digital multimeter. And we're going to go to ohms. Do we want to calibrate this probe? Yes, we are going to calibrate this probe. Okay, we're really losing daylight now. So to check resistance, we have to use channel 3 and 4. So we're not going to use our ground here. Our ground has to be connected to 3 and 4. Now you could just use 2 separate leads, or we can move our yellow lead over there. And then I'm going to disconnect just so it doesn't interfere with anything. I'm just gonna disconnect this extra lead that joins my two channels together. So now both of my channel 1 leads are connected to channel 3 and 4. Now it's asking us if we want to calibrate this probe. The way we do that is by connecting these two leads together at the other end. So I'm just going to add another alligator clip, connect those together, calibrate this probe, yes, connect these two leads together, just did that. Calibrating all scales, this will click a few times as it goes through the different resistance values. And we have 0 ohms of resistance. So now we're going to take both these off, and we're going to connect one channel to the center lead, and then we're going to connect the other one to one of the outside leads. And the outside leads should be the same value. And it doesn't matter which one you use, the resistance will be the same, either polarity we do this. But I'm just going to hook the black lead up to the center terminal. Yellow lead, let's check our side that's still functional, which was the yellow lead that we had over here. So that came out at 50 ohms, and I think that's above spec as well. Now let's go to the other side. So I'm showing open circuit on this other side. So this has failed internally and has gone open circuit. So I need a new pulse vacuum hublock solenoid. Now, even these from the dealer, you can get defective ones out of the box. It's kind of a toss-up. So, check your dealer. You can price check. The Dorman ones, I installed, one the other day and it worked perfect. I've installed them in the past and had no issues. Every once in a while, you get a bad Dorman one out of the box as well. So, it's a toss-up whether you get it from the dealer or Dorman if you're gonna get a good one. So just do your cycling, turn it on and off a few times and verify that it's gonna remain functional time after time. So I hope you found this video helpful. Keep in mind, you don't have to use the scan tool that I'm using. A digital multimeter would do the same thing. We would just check resistance, turn that little dial to ohms, check resistance between the center terminal and the outside terminals, and they should match. I don't know what spec is, but either way, those windings should match each other. If they don't, then more than likely you have a bad solenoid. But for some reason, I'm thinking like 18 to 25 is the range when they should be. If I get a new solenoid, I'll measure it before I install it, just so we have a comparison of what a brand new one measures like. So today I was using the Zeus Plus with the lab scope and the transducer adapter, and I was using the 100 PSI transducer. And then in this scope, we were using that vacuum 100 scale that's going to just show us the vacuum scale only. And the vacuum will show as a increase on the screen. It's going to show positive. So if we were using this as a pressure sensor, once it goes into vacuum, it's going to go negative. But since we were scaled to vacuum, it'll show positive. Now, if we wanted to see it the other way, we could just hit invert on the scan tool. It has that capability. So whatever you're comfortable with, we could do. Now, you don't have to use this tool to do this job. You can use a digital multimeter or an ohm meter and just check the resistance of that solenoid. You could use a handheld vacuum gauge to see if you have vacuum, going to places, just like we did at the beginning with my vacuum pump. We were basically using that as a vacuum gauge. So the fancy tools are nice, but they're not necessarily required. Where they're nice for me is I can document, the vacuum and how the system is working for my records, for the customer, whatever it may be, extended warranty. It just provides better documentation for my records. If you guys have any questions or comments on how this system works or the Snap-on Zeus Plus, then put those down below. I'll get back to you as quick as I can. If you have stuff that you want to see with the Zeus Plus, a certain video, then put that down below. I'll see if I can make that happen. If you want to see more videos like this, subscribe, click the bell. Thanks for watching, and I'll see you next time. Okay, little bonus footage. I got a new solenoid. CarQuest had one in stock. No one else in town did. So it is a Dorman unit. Let's go ahead and check the resistance of this unit. And then I didn't bring any tools home to change it out, but we can at least plug it in, hook up the vacuum lines, and then watch our vacuum with the scope and verify that everything works properly. So first, I've already calibrated these probes. One is going to get connected to the center terminal. The other one to one of the outside terminals. Let's see, 50 ohms. So I thought I said that 18 was good, but maybe I was wrong, because that's, I think, about the same as what we had on the one solenoid that was still working on that one. And this is exactly 50 ohms on both solenoid windings. Let's hook this guy up, hook up the vacuum transducer again, and I'll cycle it through a few times. And just so we get a known good, this is what the pattern should look like with a new solenoid, just in case we have one down the road that we need to diagnose, we have that saved in our scan tool. I normally save my known goods to the cloud as well, just so if I'm on a different computer or I'm not around my scan tool, I can still access them. I turn the ignition on, let the vacuum pump refill the reservoir, because it bled all that vacuum off when I changed the solenoid. Since the key is on, we can verify that I have good connection on the solenoid. Both of my leads are showing battery voltage. And keep in mind they're staggered a little bit because I have them offset. You can see on the right side of the screen, the one is lower than the number 2. And that's just so we can keep track of them a little bit easier. When they're right on top of each other, sometimes one line covers up the other line and it's hard to see which line is doing what. So I'm going to go inside, I'm going to turn the switch to 4-wheel drive. We will take a look and see what it does, how it builds the vacuum. This should run for 45 seconds. After it turns off, releases the vacuum, then we'll go back to 2-wheel drive and see how that looks. We'll save that recording just so we have a new one with a new solenoid. So the pump did kick on again as we depleted some of that vacuum in the reservoir. If I change our screen here a little bit, we can see exactly where we're at. We're currently at 12.3 inches of vacuum. That's about 30 seconds so far. A little over 13 inches of vacuum. Should be getting close to 45 seconds here. 14 inches of vacuum, and the solenoid just clicked off. The vacuum pump will continue to run until it refills the reservoir. Now keep in mind, I think we still have a very small leak in the system, but it's not that critical. 4-wheel drive system should still work, but this would have built faster if we fixed that leak. To find that leak, we'll have to isolate each side. We may have a vacuum seal that's starting to leak a little bit, or even sometimes the hubs can leak, but typically it's the vacuum seals or the vacuum lines. Let's go ahead and switch it back to 2-wheel drive. We should see about half of that vacuum. I think we were around 6.3 when we checked it the other day. And this will run for 15 to 20 seconds. So we're at 20 seconds right now. So it looks like around 25 seconds. Now I'm just gonna do what we did last night, and I'm going to exercise that solenoid. I'm gonna run it to 4-wheel drive again, back to 2-wheel drive, and just make sure that that solenoid doesn't fail with multiple cycles. So I think we had 6.3 inches in 2-wheel drive mode last night. Now we have a little over 7. I did not calibrate the probe, and we can see the probe is off a little bit, so our vacuum actually might be a little bit higher, so 7.3. But either way, it's about half the vacuum to switch to 2-wheel drive as it is to go to the 4-wheel drive mode. I think that wraps this one up. If we run into any other issues, we'll revisit this in another video where maybe we can check the vacuum seals, and if one's bad, we'll go ahead and replace that. Thanks for watching, and I'll see you next time.